Welcome to BSc Statistics students. In this class, I explain the fitting of logistic curve by the method of successive approximation. I have discussed all the methods. 4 methods you have to fit the logistic curve. In this method, I explain method of successive approximation. By the method of successive approximation, how to fit a logistic curve. So first of all, I consider logistic curve. What is logistic curve? It is yt is equivalent to be yt is equal to k by 1 plus e power a plus bt. That you consider, it is equation 1. This is what our logistic curve. So if this is the logistic curve by the method of principle of least squares, if we want to consider the first correction, for example, you have to assume that, let us assume the k, a, b are the values and the parameters which are known approximately, and then by the method of principle of least squares, if you consider the first correction for k, a, b are which are for example mu, lambda and delta. The first correction for k, a, b are, for k is mu and for a it is lambda, for b it is delta. If we consider these are the first correction for the parameters k, a, b. Then what is our equation? I write therefore yt is equivalent to be k plus mu. This is what the correction for k, and 1 plus e power a plus lambda plus b plus delta into t. This is what the, after first correction, this is what yt, the value of the time series, variable of the time series. Now what I consider, mu, lambda and delta are the values approximately equal to 0, tending to 0, which are small positive quantities. This is what I consider mu, lambda and delta, the small positive quantities. So by, if you expand this, that is I write one more step here. This is what you can write as k plus mu divided by 1 plus e power, what I write a plus bt, that is one expansion on the term I write, plus, which means multiplied by, I write e power lambda plus delta t. This is what the term I consider. I separate the terms, two particular terms, a plus b into t is one term, lambda plus delta into t another term. Because of e power a plus b, that we can write as e power x plus y, you can write e power x into e power y. So now I consider e power the expansion e power lambda plus delta t, which is nothing but e power x expansion. It is 1 plus lambda plus, that is delta t, that is 1 plus x plus x square by 2 factorial lambda plus delta t divided whole square divided by 2 factorial plus x cube by 3 factorial and so on. If you consider this, because of the quantities lambda and delta are very small positive quantities, then we can consider, we can ignore remaining all except this one. So I am writing this is 1 plus lambda plus delta t. Okay, this is what e power lambda plus delta t. So this is, I am ignoring remaining square terms etc., the remaining powers, higher powers, all higher powers I am ignoring, so that e power lambda plus delta t I am expressing as 1 plus lambda delta t, 1 plus lambda plus delta t. Okay, so that if I substitute there in the equation, what you will get, yt, therefore yt is equal to yt is equivalent to be k plus mu divided by 1 plus e power, this is the term, 1 plus e power a plus bt multiplied by what I can write as e power lambda plus delta t. I am writing as 1 plus lambda plus delta t. You got the term right here instead of this particular term, right? So therefore, yt is equal to this. So if you consider this, this we can express as this is, I'm taking this particular term in the numerator so that this can be expressed as that is x power minus 1. 1 by e 1 plus that is 1 plus e power a plus bt into 1 plus lambda plus delta t, that I am writing, the whole power minus 1. This is the term I am taking in the numerator so that this is k plus mu into 1 plus e power a plus bt into 1 plus lambda plus delta t, the whole power minus 1. Just I have taken this one particular term in the numerator. That's it. Okay. Hereafter, what I do, I divide and multiply with the entire term. That is this particular term with 1 plus e power a plus bt. I divide and multiply with this particular term. So that what you will get. So which is then yt becomes yt is equal to k plus mu multiplied by 1 plus e power a plus bt divided by 1 plus e power a plus bt multiplied by the term here 1 plus e power a plus bt multiplied by 1 plus lambda plus delta t, the whole power minus 1. If you consider, if you take one particular term into the inside of this particular factor, whole power minus 1, then dividing this particular factor, so that is equivalent to be k plus mu. Hope you understand. I am taking this particular term inside in the numerator term, that is k plus mu divided by this becomes 1 plus e power a plus bt. I am leaving this particular term here. Do you understand? K plus mu divided by 1 plus e power a plus bt I am leaving here, and this particular term I am taking into the power minus 1. That is this, if you take this particular term, it will be in the numerator because power minus 1. Therefore, 1 plus e power a plus bt into 1 plus lambda plus delta t, okay, divided by 1 plus e power a plus bt. It becomes in the denominator because power minus 1. So 1 by x whole power minus 1 becomes x. So 1 by 1 plus e power a plus bt is nothing but again 1 plus e power a plus bt. So therefore, this particular term we are taking inside of the term. So therefore, now you see, now what I am doing, k plus mu and divided by 1 plus e power a plus bt and multiplied by this particular term what I am writing here. I multiply this particular value e power a plus bt with 1 and lambda plus delta t. 1 into e power a plus bt, that is e power a plus bt, plus and now e power a plus bt into lambda plus delta t. Okay. Now divided by 1 plus e power a plus bt. Okay. Whole power minus 1. Now you see, if you divide this, if you consider this is x, this is y, x by x, it is 1, plus this by this. That's all, right? One more time, I write in the next page. Hope you understand this. This is what? The yt. Therefore, yt is equivalent to be, now what is yt? Therefore, our yt is equal to k plus mu divided by 1 plus e power a plus bt, okay, multiplied by, now multiplied by this is the term 1 plus e power a plus bt divided by 1 plus e power a plus bt will get cancelled. It is 1 plus next term e power a plus bt, e power a plus bt multiplied by lambda plus delta t divided by, only for this particular term, e1 plus e power a plus bt, the whole power minus 1. The whole power minus 1. What is this? This is yt. Whole power minus 1. So for which if you express this particular term 1 plus x whole power minus 1, the formula, what is the formula of 1 plus x whole power minus 1? It is 1 minus x plus x square plus x cube and so on. That is the formula. So hence, shall I write here 1 plus x the whole power minus 1, the formula is equal to 1 minus x plus x square minus x cube plus minus and so on. This is the formula. Therefore, now yt becomes, therefore yt is equivalent to b. You see, refer this, and while doing this, k plus mu divided by 1 plus e power a plus bt multiplied by, I am writing three terms. Okay, 1 minus x first of all. X means this. What is this? E power a plus bt into lambda plus delta t divided by 1 plus e power a plus bt. This is x plus x square plus e power a plus bt into lambda plus delta t, the whole square divided by 1 plus e power a plus bt, the whole square, x square. So minus plus and so on. I am writing just only the two terms, that is three terms, including 1, 2, 3 terms, right? Again, you see here lambda and delta, the two particular small positive quantities, the higher powers of lambda and delta I am ignoring, and so that I am considering only the first two terms, 1 and this. Higher powers from the second, third, that is 2, 3, 4 and so on, I am ignoring, so that this term becomes, this is equivalent to b, k plus mu divided by 1 plus e power a plus bt into multiplied by 1 minus e power a plus bt into lambda plus delta t divided by 1 plus e power a plus bt. This is what the term which remains here. And so that now if you multiply this particular term with the k plus mu divided by 1 plus e power a plus bt inside, so that the two particular terms, this into 1, therefore k plus mu divided by 1 plus e power a plus bt, that is first term, minus, if you multiply with this k plus mu multiplied by e power a plus bt into lambda plus delta t divided by 1 plus e power a plus bt into 1 plus e power a plus bt, the whole square, therefore whole square. This is yt finally. This is what yt. Now, if you separate the terms according to the terms which is k with in terms of k, mu, lambda and delta, right? So that we specify k by 1 plus e power a plus bt, mu by 1 plus e power a plus bt. Now what I am doing, x plus y divided by some z, x by z plus y by z. So k by, is it clear? Right. K by 1 plus e power a plus bt plus mu divided by 1 plus e power a plus bt, okay, minus the remaining terms I write here. I multiply with k plus mu and lambda plus delta t, 1 by 1. If you multiply here, clearly k into lambda, okay, k into lambda, first terms with minus, because here we have minus, all the terms are minus, okay. minus k into lambda into e power a plus bt divided by 1 plus e power a plus bt the whole square. This is next term. Okay, and remaining terms are right here, minus k multiplied by delta t, k delta t multiplied by e power a plus bt divided by 1 plus e power a plus bt the whole square. Is it clear? Right. Next term, multiply with mu multiplied by lambda minus mu multiplied by lambda into e power a plus bt divided by, this is b, this is t, divided by 1 plus e power a plus bt the whole square, minus one more term we have to write, that is mu multiplied by delta t, that is mu delta t multiplied by e power a plus bt, a plus bt divided by 1 plus e power a plus bt the whole square. Clear? This is what yt. There are 6 terms. But I am ignoring again the terms of them because mu, lambda and delta are very small positive quantities. I am ignoring the terms mu lambda and mu delta. So mu lambda and mu delta. So that the terms here, mu lambda term, this is, I am ignoring this. Mu delta, I am ignoring this. These are the 2 terms which are the small positive quantities, and remaining the terms I consider. And so that the finally what you have the yt, I write here, therefore yt is equivalent to be k divided by 1 plus e power a plus bt first term, and plus mu divided by 1 plus e power a plus bt the second term, minus k lambda into e power a plus bt divided by 1 plus e power a plus bt the whole square, minus k delta t into e power a plus bt divided by 1 plus e power a plus bt the whole square. These are the terms, 4 terms we have kept here in this particular at the end of the variable yt after approximation, one particular approximation by considering here by using the method of principle of least squares. Now we have to consider consider into a particular form that so that it is going to be obtained. The at that I am considering, at is equivalent to be some k by 1 plus e power a plus bt. That is what I have considered at, and bt, I am considering bt is equivalent to be 1 by 1 plus e power a plus bt. This is what I am considering bt, and ct, or I am considering ct is equivalent to be, is it visible? Right. Ct is equivalent to be, in this particular term I am considering k into e power a plus bt divided by 1 plus e power a plus bt the whole square. The term I consider ct, and dt, that is at the time period t, I am considering dt. Dt is equivalent to be, in this particular term, by leaving delta, kt into e power a plus bt divided by 1 plus e power a plus bt the whole square. If you consider like this, then what you have, what would be the yt? Then yt is equivalent to be at first of all plus mu 1 by 1 plus e power a plus bt we have considered as bt. Therefore, this is bt into mu. Next one, we have considered in this, except lambda, we have considered k into e power a plus bt divided by 1 plus e power a plus bt whole square as ct. Therefore, ct into lambda. Hope you understand why you are considering in this fashion, in this way, right? So So therefore, the last one, kt into e power a plus bt divided by 1 plus e power a plus bt whole square. We have considered dt. So therefore, dt multiplied by delta. That is the parameters mu, lambda and delta are going to be obtained by using the method of principal of least squares. Therefore, at, bt, ct and dt are known, and the linear trend is going to be considered, and since k, a, b are known, and therefore by using the method of principal of least squares we can estimate mu, lambda and delta. Therefore, with these values we can obtain the best fit of the logistic curve for the parameters k, a, b. We have to obtain k, a and b, which are by considering the linear trend is known, we have to consider in this fashion, and we have to go and approximate the first approximation. By using this particular successive approximation, we have to calculate the parameter, we have to estimate the parameters k, a and b. You understand? Thank you. Thank you very much.